Hi guys, welcome to my channel. In this video, I'm going to explain the processes. In my previous video, I explained about the procedures, characteristics, representation and application. Now let's see what are the characteristics, representation and applications in the processes. I explained about the processes in my previous video. If anyone are coming without watching that video, please watch that video first and come to this video so that you can understand this classification and representation more clearly. So let's see what are the characteristics. So the first one is temporal nature. What is this temporal nature? So the temporal nature is nothing but the changes which occur over the particular duration of the time. So what are the changes are occurring while doing the event or the action? So that changes over the time is nothing but the temporal nature. What is the nature of the time? So that is the meaning. So we have to know the specific time interval. So when the changes occurred. Okay. Next, causal relationship. What is a causal relationship? Causal relationship is the cause effect relationship between the two events, which I explained in my classification of the process when I'm explaining, so that I'm saying to watch that video and come to this video so that you can understand this thing. So causal relationship means it is like a cause and effect relationship. Like example which I explained, like smoking to lung cancer. Smoking is linked to the lung cancer. How it is? Like to have some cause and effect relationship between the two events, or the we can say action. So this is known as the causal relationship, where we'll be predicting the outcome, we'll be predicting the output. Okay. Next is dynamic behavior. What is a dynamic behavior? Process can be dynamic, involving change in the state. So according to the change, it will be changing. According to the state, it will be changing. Concurrent actions. So multiple tasks will be performing at the same interval of time. So that are the concurrent actions, like multiple actions, multiple tasks will be performing at the same duration of time. At the same time, multiple actions will be performing. Next is probabilistic event. Is randomness of event occurrence. Okay, randomness of event occurrence. It's like occurrence of the event or the action is the subject to uncertainty or the randomness. So the result can be certain or uncertainty also, which may correct or may not correct. So it's like a probability. Yes or no? Like example, if you roll a die, we may get 6 or we may not get 6 also. So it's like a probability. Occurrence of 6 and not occurrence of 6. Okay. These are the characteristics of the process. Next, let's understand what are the representation of processes. Temporal logic. What is temporal logic? So it is nothing but a formal language for expressing temporal properties and the reasoning about the temporal relationship between the events. Will be having some relationship between the events, like smoking to lung cancer. So smoking is one event, lung cancer is one event. So where it will be having some relationship between the two events. So in that way. So in this we'll be having some model operators, which are next. What is the next event? Until this event, eventually. So these are the three things which we'll be using, which are there in the model operator. So by this we can represent the temporal constraints and the dependencies. By using this thing, we can represent the temporal constraints, means according to the specific conditions and their dependencies. These are the things. Mainly temporal logic is nothing but to express the temporal properties and the reasoning to how to express this temporal properties using this temporal logic. So we'll be having some relationship between the events. Okay, these are the things. Next is event calculus. What is the event calculus? This event calculus and the situation calculus I explained when I'm explaining the classification of processes. Event calculus is nothing but the representing and the reasoning about the events and their effects, and we'll be using this event calculus in the first order logic also, and representing the states, events, this whole thing I explained. Next, situation calculus. What is the situation calculus? It's like a framework for representing the representing and reasoning about the dynamic domain which involves actions and change over the time. Okay, it allows representation of situation, action, and the event using the logical predict predicates and inference rules. So these are the representation. So we can representation, already this thing I explained in the classification only. So small modification, temporal logic, and event, situation. So time, event, situation, this is the representation. In these three ways we can represent the process. So what are the applications? This thing also I explained, I think. Temporal reasoning, event modeling, situation awareness. When I am explaining the classification of the process, I included all these points. As or no? So I will be providing that video link also in my description. So watch that video and come to this video. And so basically, which I said before only, just remember the side headings, so that by the side headings you can write your theory in your own words. So understand the concept. So the main impact is to understand the concept. If you will not understand the concept, you can't write. So because we'll be having so many side headings, so you cannot remember that many side headings. So first you have to understand the concept. So if you understand the concept, you can remember the side headings and you can write by your own also. So this is about the process, and that's it for this video. And in my next video I will be explaining about the histories. And that's it for this video. Thanks for watching. Let's meet in next video.